Welcome back everyone to another lecture in our CMRP preparation course. In this video, we are going to learn about the total productive maintenance losses, or what we call the overall equipment effectiveness. So in our last lecture, we explained what do we mean by TPM, and we explained its objective and the main tools. And we stated that it has 5 principles, 8 pillars, and 6 losses. And we explained the 5 principles and the 8 pillars. Losses that TPM aims to eliminate are the following: equipment failures, which are the system's breakdown; setup and adjustment, which is the time spent in setting up the system or carrying out minor adjustments; minor stoppage, which occur due to operation issues not because of an actual breakdown; slow speed, which is a performance issue of the operators; process defects, which is the quality of the work done; and finally, reduced yield, which is because of the reworks. So how can we measure and assess those 6 losses? In order to measure those 6 losses, we came up with what we call overall equipment effectiveness, which is also called the OEE. And OEE is a metric that is used to measure how well an asset or process is operating. The OEE for any equipment is a result of the following equation: OEE equals availability multiplied by performance multiplied by quality. As you can see here, availability measures the equipment failure and setup adjustments, and it equals the asset's uptime over the total uptime plus downtime, while performance measures the minor stoppage and reduced speed, and it equals actual production rate over the designed production rate, and finally quality, and it measures the process defects and the reduced yield, and it equals the good units produced over the total units. So best practices of those parameters are 90% for availability, 95% for asset performance, 99% for asset quality, which means that the best practice for the OEE is to be more than 85%. If our equipment has a higher OEE, this means that we are exceeding the best practices. And if our equipment has a lower OEE, it means that we have an issue in our system that has to be solved. Once we calculate the overall equipment effectiveness, we will be able to calculate another measure, which is the total effective equipment performance, which is also called TEEP or TEEP. And TEEP is a result of the OEE multiplied by utilization. And the utilization is the time I choose to use the system, which means how many hours per day and how many days per year I choose to operate. And the best practice for the utilization is 98%. So TEEP actually equals availability multiplied by performance multiplied by quality multiplied by utilization. It is important to memorize the best practice percentage for those parameters, as you will need them in the CMRP exam. So now let's have an example on this. How would you evaluate the performance of a certain asset in an organization if it had a total of 240 downtime hours in the last scheduled 2000 production hours, and its performance is calculated as 93% and the quality of the production is 95%? So in this case, we need to calculate the OEE, which equals availability multiplied by performance multiplied by quality. In order to calculate the OEE, we need to calculate first the availability. And we know that availability is the uptime over the uptime plus downtime, which is the scheduled time. So if the downtime has been 240 out of 2000 scheduled hours, this means that the uptime hours is 2000 minus 240, which is 1760 hours. This means that the availability equals 1760 over 2000, which will be 88%. Now we can easily calculate the OEE, which will equal 88% multiplied by 93% multiplied by 95%, which will equal 77.7%. And we know that the best practice for the OEE should exceed 85%. Then our system is underperforming. and we need to investigate what is the issue in the system in order to rectify it. I know this might be a little confusing, and this is why I have created for you this bar chart, which will make it very easy for you to understand the difference between each one of those definitions. At the top here, you can see the total available time, and this is the total possible time for production that we can have during the year, which is simply 24 hours per day multiplied by 365 days per year. Out of the total available time, we have this actual scheduled time for production. The remaining duration here are idle time, so those losses here represent the utilization losses, and those losses shouldn't exceed 2% as per the best practices as we have agreed earlier. Out of the scheduled time for production, here we can see the actual uptime of production, which is the total scheduled time minus the downtime losses. So the losses here are considered as the availability losses, and these losses shouldn't exceed 10% as per the best practices as we have learned. Those uptime hours should provide us with a certain production volume based on the best production rate. However, this doesn't occur, and this is because of the system is running slower than designed rate. So these losses here are due to slow speed, which are considered as the performance losses, and these losses shouldn't exceed 5%. And after that, we will find out that not all the production meets the quality passing criteria. So we have here some losses due to the defective production, which are considered as the quality losses, and these losses shouldn't exceed 1% as we have learned. So here, if you divide the scheduled hours over the total available time, you can get the utilization, which should be higher than 98%, and if you divide the uptime hours over the scheduled hours, you get the availability, which should exceed 90%, and if you divide the actual production over the best production, you get the performance, which should exceed 95%, and finally, if you divide the good production over the actual production, you get the quality, which should exceed 99%. So now, let's have an example on this. Here we have an equipment working 2 shifts per day. Each one is for 8 hours. The planned maintenance time per shift is average of 30 minutes, and the unplanned maintenance yesterday was 2 hours. This equipment is designed to produce 20 units per hour. However, it was noticed that it is producing 18 units per hour lately, and the equipment has an average of 1 failed unit out of each 50 produced item due to quality issues. Calculate the total effective equipment performance for that equipment based on yesterday's performance. Okay, so we know that TEEP equals OEE multiplied by utilization, and we know that OEE equals availability multiplied by performance multiplied by quality. So the first step is to calculate the utilization, and the utilization for this equipment is 2 shifts for 8 hours each, which means 16 hours over 24 hours a day, which means that the utilization yesterday was 66.6%. Next step is to calculate the availability, and the availability is the uptime over the scheduled time, which in this case is 16 hours minus 0.5 hour for planned maintenance and 2 hours for unplanned maintenance over 16 scheduled hours. So the availability is 84.4%. Next step is to calculate the performance, and the performance equals the actual production over the designed production, which is 18 over 20, which equals 90%. And finally, we calculate the quality, and the quality is the acceptable production over the total production, which is 49 over 50, because we know that the equipment produces in average 1 defective part out of each 50 units, so the quality equals 98%. So now we can calculate the TEEP, which will be 66.6 multiplied by 84.4 multiplied by 90 multiplied by 98, which equals 49.5%, which means that this equipment effectiveness is way below the best practice level. And here it is obvious that the part which is mostly affected is the utilization. So if we enhance it, we can end up with a better TEEP. because quality is 98%, which is not far from the best practice level, and performance is 90%, and availability is 84.4%, which both of them are not so far also from the desired levels. But utilization, which is 66.6, is the aspect which greatly falls behind the best practice desired level. So, this was our last lecture in this pillar number 2. I hope you have enjoyed it, and see you in our next pillar. Thank you.